Good day everyone, and welcome to this video. Today we are going to talk about three configurations, which are Fano plane, Möbius-Kantor configuration, and Reye configuration. So what is Fano plane? In finite geometry, the Fano plane, named after Gino Fano, is the finite projective plane of order 2. It is the finite projective plane with the smallest possible number of points and lines, 7 points and 7 lines, with 3 points on every line and 3 lines through every point. The standard notation for this plane as a member of a family of projective spaces is PG 2, 2, where PG stands for projective geometry. The first parameter is the geometric dimension, and the second parameter is the order. The figure on the right is the Fano plane. As you can see, it has 7 points and 7 lines, with 3 points on every line and 3 lines through every point. So, the Fano plane is an example of a finite incidence structure. So many of its properties can be established using combinatorial techniques and other tools used in the study of incidence geometries. Since it is a projective space, algebraic techniques can also be effective tools in its study. So who is Gino Fano? Gino Fano, born on January 5, 1871 and died November 8, 1952, was an Italian mathematician, best known as the founder of finite geometry. He was born to a wealthy Jewish family in Mantua, in Italy, and died in Verona, also in Italy. Fano made various contributions of projective and algebraic geometry. His work in the foundations of geometry predates the similar, but more popular, work of David Hilbert by about a decade. Gino Fano was also the father of physicist Ugo Fano and electrical engineer Robert Fano, and uncle to physicist and mathematician Giulio Racah. So what is the Möbius-Kantor configuration? In geometry, the Möbius-Kantor configuration is a configuration consisting of 8 points and 8 lines, with 3 points on each line and 3 lines through each point. It is not possible to draw points and lines having this pattern of incidences in the Euclidean plane, but it is possible in the complex projective plane. The figure on the right is the Möbius-Kantor configuration. As stated in the definition, it has 8 points and 8 lines, with 3 points on each line and 3 lines through each point. More abstractly, the Möbius-Kantor configuration can be described as a system of 8 points and 8 triples of points, such that each point belongs to exactly 3 of the triples, with additional conditions, natural to points and lines, that no pair of points belong to more than one triple, and that no two triples have more than one point in their intersection. Any two systems of this type are equivalent under some permutation of the points. That is, the Möbius-Kantor configuration is the unique projective configuration of type 8 sub 3, 8 sub 3. So the Möbius-Kantor configuration was named after August Ferdinand Möbius. Möbius was born in Schulforta, Electorate of Saxony, and was descended on his mother's side from religious reformer Martin Luther. He was homeschooled until he was 13, when he attended the college in Schulforta in 1803 and studied there, graduating in 1809. He then enrolled at the University of Leipzig, where he studied astronomy under the mathematician and astronomer Carl Morvide. August Ferdinand Möbius was born on November 17, 1790, and died on September 26, 1868. So what is Reye configuration? In mathematics, the Reye configuration, introduced by Theodore Reye in 1882, is a configuration of 12 points and 16 lines. Each point of the configuration belongs to 4 lines, and each line contains 3 points. Therefore, in the notation of configurations, the Reye configuration is written as 12 sub 4, 16 sub 3. The Reye configuration can be realized in 3-dimensional projective space by taking the lines to be the 12 edges and 4 long diagonals of a cube, and the points as the 8 vertices of the cube, its center, and the 3 points where groups of 4 parallel cube edges meet the plane at the infinity. So what is Reye configuration? In mathematics, the Reye configuration, introduced by Theodore Reye in 1882, is a configuration of 12 points and 16 lines. Each point of the configuration belongs to 4 lines, and each line contains 3 points. Therefore, in the notation of configurations, the Reye configuration is written as 12 sub 4, 16 sub 3. The Reye configuration can be realized in 3-dimensional projective space by taking the lines to be the 12 edges and 4 long diagonals of a cube, and the points as the 8 vertices of the cube, its center, and the 3 points where groups of 4 parallel cube edges meet the plane at the infinity. The figure on the left is the Reye configuration. It has 12 points and 16 lines. Each point of the configuration belongs to 4 lines, and each line contains 3 points. The Reye configuration can also be realized by points and lines in the Euclidean plane, by drawing the 3-dimensional configuration in 3-point perspective. An 8 sub 3, 12 sub 2 configuration of 8 points in the Reye projective plane and 12 lines connecting them, with the connection pattern of a cube, can be extended to form the Reye configuration, if and only if the 8 points are a perspective projection of a parallelepiped. The Reye configuration was named after Carl Theodor Reye, who was born on June 20, 1838 and died on July 2, 1919. He was a German mathematician who contributed to geometry, particularly projective geometry and synthetic geometry. He is best known for his introduction of configurations in the second edition of his book, Geometry of Position. Reye obtained his PhD from the University of Göttingen in 1861. His dissertation was entitled The Mechanical Theory of Heat and the Potential Law of Gases. Reye also developed a novel solution to the following 3-dimensional extension of the problem of Apollonius. Construct all possible spheres that are simultaneously tangent to 4 given spheres. That is all for this video. Thank you for watching.